Okay, so it seems that there's major confusion, and I want to believe that it's from the weather situation that we had from the other week. However, there are no changes currently, and I'm just going to come back to here because it seems that a lot of people are confusing things for no reason. So make sure to go here to the syllabus, and then if you click it, it'll take you open to our schedule. Go to the bottom. We're Group C. Give it a second. Okay. So make sure that you've completed your quizzes and notebooks for the 2 experiments, fractional distillation, simple distillation. And this week we're going to be doing understanding the polarimeter. If you're ever curious on what we're doing, always refer to the syllabus. We're going to be strict back on the schedule now until, if something else crazy comes up, which would not be a surprise at this point with what's going on in the world. So we'll just go ahead and go through the polarimetry stuff this week, and then prepare yourself for separation of the organic composites of acid through acid-base extraction. So let me switch back real quick. And again, if you are confused on anything, always feel free to contact me, but make sure to go ahead and look over at the syllabus before, emailing and saying, hey, what are we doing this week? Because that's been happening consistently. And I feel like if every time that we have a Zoom call, I refer to going to look at the syllabus, it means that you aren't doing the effort on your part, which is unfair for me. So make sure to look at the syllabus every week if you need to know what we're going to be focusing on this week. So let me look. So this week I'll be going easy on everybody in terms of the pre-lab. So make sure next week that everyone has the pre-lab completed, that we all know that we're going to be doing the separation of acids and bases by extraction. And I'll say it over and over again, even I'll remind everyone at the end of the day. And then we will go forward. Make sure that you're on time for these labs from now on for anyone here that might be showing up late, just because we're starting, a few minutes late as well. And we're still having people come in. I know it's early, but I'm here too at this time. And so I'm going to be saving more attendance again, but we all need to make sure we're on time. So let's go forward and actually focus on the material at hand that we are going to be looking today at polarimetry. So firstly, the lab manual we'll be utilizing in order to review what the subject is that we would be performing in the lab. Go ahead and watch all of these videos because there are multiple videos, so the same situation as before, that we won't be going through all of these in class today. However, I will be reviewing certain parts of video number 1, because that way everyone can actually see the experiment being performed, since the lab manual is very detailed for this experiment. However, it's not as good as if you were to actually see somebody performing this experiment in person, or if you were performing the experiment yourself. So then, of course, the pre-lab, make sure that you're writing up your lab notebook. And if you need any more instruction onto how to complete your lab notebook better, make sure to watch one of my videos from last week, because I did an in-depth analysis of the lab notebook as well. Over here, if you go to files, then you can go down into, let's see where it is, lab notebook example. And then here is an example that you can click in order to review that, just so that way that you make sure that your formatting is good. Make sure, and I'm just going to do a quick run through of things that come to mind so that way that people don't lose points. Make sure to list out all of the instruments, which are the machines that you'll be utilizing in this experiment, such as the LabQuest or the polarimeter. Then make sure that you list out all of the apparatuses, which are all of the glassware. Make sure that you put the size of the glassware, because if you just place beaker that could be a very small 25 milliliter beaker, or it could be a liter beaker. And those are significantly different if you were performing, more rigorous reactions that you need to be careful with. So just make sure that you're really specific, that when you create your lab notebook, it's as if that you were creating it and having to walk into a lab and perform that experiment entirely without referring to any other materials. So once it's completed, it needs to be like you ran the entire experiment and that you could walk in and replicate everything that you wrote down. Again, the pre-lab quiz, make sure that everyone's completed that by Friday. Let me know. Again, if anyone has not completed any of the materials that we have, from the past 2 weeks. I understand everyone has different situations going on from the weather, so we'll accommodate it by a case-by-case basis, but make sure to reach out for me, so that way that I'm not just like going through grading and then I see that you didn't have something turned in. And yeah, so post-lab notebook as usual, and then we'll review the data after we go through our lab manual. So this time I'm gonna skip through here a little bit so we can review this video together and just kind of see the main things. I'm not gonna watch the whole thing because it's 20 minutes. Today will be a shorter class period just because it's pretty straightforward and swift. So we'll go ahead and go over here. So polarimetry, what we're performing, we're experiencing how the sample path length and concentration affect observed rotation of a given compound. And we're going to be utilizing Voigt's law in order to calculate our specific rotation. And the thing we'll be analyzing in lab would be a sugar sample of different forms of sugar. And it'll give a better explanation when we review the lab manual. I just wanted to actually get through here mainly. And I'm going to go ahead and skip through the Voigt's law because we'll be reviewing this in the lab manual into a deeper understanding. So coming over to here, the main things are that we would be buying lab grade sugars, sucrose, galactose, fructose, and then we'd be making them into specific dilutions shown on the right in the volumetric flasks. So when you utilize a volumetric flask, and this is going to be pretty crucial if you have to go forward to take any form of analytical chemistry classes, that what you want to do is place the sugar into the volumetric flask or whatever you're dissolving in there first, and then you fill up the line with your deionized water in order to make sure that you have a certain percentage of solution. So this is 10% sucrose would mean that you're putting 10% by weight into a total amount of, let's say, 100 milliliters for this example. So you wouldn't fill it up to the line and then add sugar. You would put the sugar in and then fill it up to the line, so that way you have a standard solution of a certain concentration. And so sugar can be considered either organic or aqueous waste, since technically sugar does have carbons on it. However, I would consider it personally more of an aqueous waste since it's water soluble. So within the lab, whenever you think of something that is highly water soluble, like salts, that's a great example. Any sort of like sodium bromide or anything that is an ionic pair, those are more considered aqueous waste. However, in the case of sugar, since it's a carbon branched molecule, it can be either or. So, however, if it was like an A or B situation, and they like said, pick one and that's it, I would say aqueous just because sugar is water soluble. So let's go forward. So those are our volumetric flasks filled with our solutions. And then going forward, this is where we would be weighing out our solution, or weighing out our sugar in order to place them into our volumetric flask. So everyone, I assume, has taken Gen Chem 1 at this point and used to scale and know how to weigh things. Then, so see, we place the sugar into our volumetric flask and then we fill it with water. So that way we have an explicit percentage solution. So scooting forward. Okay, now this is the part I really wanted to show everyone here, because this is an important thing, is the polarimeter itself. So this part's just the concentration. Scooting forward. Okay, so this is the polarimeter right here on the left. This thing here that looks like a little elevator or something. And so what we're gonna do is that we would take our LabQuest and we connect it through these sort of USB or Ethernet ports that connect from the LabQuest into the polarimeter in order to analyze the data. And it actually transmits the data directly to the LabQuest. So these are the machines that are going to be utilized, as well as the scale, if you wanted to make a side note for your lab notebook. So see, once we open it up, we get ourselves a little like graph that has all of the settings that are within the LabQuest. And going forward, so here's we have our solution here. And I don't remember right now if this is just the DI water or if it's the sucrose, but we go ahead and come here. I think this is just the DI water in this case to run the blank first. So you would run a blank, get a standard blank, and then that would be in order to calculate further whenever you run your samples, the specific degree of rotation. So, we always use a blank whenever we're performing in labs and have to measure something like absorbance or anything, there's always a standard that we need to subtract. That's kind of like a base that's going to remove from the total value of our concentration. And so, again, review this so you can hear what she's saying during the video. But the main thing I wanted to show you was the polarimeter and the LabQuest connected together. So you know what machines you're using and also what they look like. But make sure to review all these videos that are given in the module. And also I wanted to go ahead and show exactly how it's used. So see, now she is rotating the polarimeter in order to observe this full sinusoidal wave. Now, once the data has fully been collected, then we go forward. And so here we select the section on the LabQuest that we are analyzing. Then we're going to go ahead and click Curve Fit Illumination. And this is just like whenever you're utilizing, your scientific calculator in order to analyze a graph and take the best fit in order to, solve for some sort of quadratic or some sort of equation within the calculator and analyze it from there, because obviously you can't just look at a graph and say, oh, this is exactly the equation. You'd have to, utilize your formula in here. So fortunately, what LabQuest does for us is it goes ahead and performs the expression for us. So we do a Gaussian fit in this specific situation. And then what we use is the point B. So that is what we would be utilizing within LabQuest. So once again, you'd run your experiment, performing the polarimetry, rotating it. Then all of the data transmits to your LabQuest. Then you go in, you analyze the data, fit. You would utilize Gaussian as the equation, and then the coefficient of B is going to be the specific angle of rotation that we would be taking from here. And then I believe the rest of the video is just, going forward and then utilizing the different samples and then, performing over and over. Once you do it, the experiment is the same as the analytical experiment. You make your dilutions and then you run each individual experiment the exact same way, the exact same fit, the exact same analysis, such that we can perform it and understand each individual specific rotation. So make sure to go ahead and review that at your earliest convenience, and make sure to review all of the material for the quiz. So we did have a little bit of a rough start on the quizzes, I think, for either the second or third quiz, but it looks like everyone's doing better now, and we're utilizing resources that are providing us with ample information. So I wanted to say, y'all are doing a great job so far with getting through, especially all of this craziness with the weather and everything in the world. So, I want to say thank you to everyone for sticking it through, and always feel free to reach out. I try and answer questions as soon as possible. And if not, I'm busy too. I'm taking classes as well. So sometimes I might not be able to answer, but I'll try and make sure that I get a good answer, or at least a good direction to get everyone going. So that way that I can be as of as much assistance as possible. So now, okay, so again, it'll be super, super fast today. So make sure in your lab notebook, we're going to be as critical as possible with how much of your procedure. Y'all have been doing great on your procedures, by the way. The main thing that I just saw from grading the first rounds was to make sure that your machines and apparatuses are listed, very, very distinctly, and to give as much depth towards your lab notebook as possible, such that you could walk in and replicate it. And I always want to repeat that, just because, when you're performing stuff, and this will even just be a good example I have here, when you're performing stuff in lab and you're looking at a paper, do you see how much stuff is here? This is just an example of all the stuff that I have to look through just to get one specific reaction, just one reaction. And that's just a real life example. So if I don't take every single word by word information out of this specific portion of this, massive paper, then I don't know what to do in the lab. And this is a real life example. This isn't just, oh, I'm gonna go measure some sugar. You gotta use as much detail as possible. Otherwise, you may not only put yourself into a safety situation where you could potentially be in harm, but also you might just mess your experiment up and waste not only time, but resources. So, give as much detail as you can within these experiments, especially these ones that are a little bit swifter. Like this one is pretty swift because we're only focusing on polarimetry. So make sure, if you don't comprehend exactly what's going on here, to utilize your chemistry book. Make sure to, Google is a great resource, whichever way that you learn well. Khan Academy, awesome resources, all available online. Most of my learning has been, I'd say a good amount was from textbooks, but then a good amount is honestly YouTube and other Google resources where you just say, Scott, I don't understand this. Can you help me a little bit? Then sure. Chemistry is my favorite subject, so I'm always willing to, guide everyone in the right path, so that way we can get through this class together and everyone can understand and learn the material at hand. So going forward, let's go ahead and review here polarimetry. So this is, again, one of the parts where they, utilize examples and explain to you why we perform polarimetry, such as situations where we're analyzing amino acids, nucleic acids, carbohydrates, lipids. Probably everyone's learning about enantiomers and chiral molecules currently if you are in Organic Chemistry 1. If not, definitely look up enantiomers, chiral molecules. They have specific rotations in specific places on a compound where each individual molecule has a greater precedence, meaning that the compound is facing a certain way. And there are many different types of compounds that are very important where they have chiral centers, such as ibuprofen. I believe that's the one that the one form of its chirality is very active, and then the other form is nothing. So if somebody messed up in a lab and created ibuprofen in the inactive form and you take it, you would have no effects from it. So going forward, looking here, the main ideas that we want to review are going to be an enantiomer in the positive form. A positive enantiomer rotates the plane of a linearly polarized light clockwise, or dextro, as seen by the detector, and a negative enantiomer rotates the plane counterclockwise, which is levo. And so the good way to remember this, with the clockwise is dextro and the counterclockwise is levo. I always remember counterclockwise, levo, left. So, goes towards the left. Probably my camera's, going the other way, but if you think about it, going left, levo is left, and then dextro is right. I don't have a good way for dextro, so good luck on that one. So going forward, basically, we look through, if we were utilizing a different form of machine in this situation, we'd be looking through a sort of microscope, if you will, and turning it until we get to a specific degree where light polarizes straight through our compound. And so when we do this, we have to use a standard, and after DI water is always our standard for everything when we're performing analytical chemistry. So we'll look at this specific thing called Boyd's law, and this is very, very important for polarimetry, where the alpha is the observed optical rotation in units of degrees. So we're using degrees because we're doing clockwise and counterclockwise, so degrees from 0 to 360, and it'll either be positive or negative from the axis. If it's to dextro, to the right clockwise, it's positive. If it's levo to left counterclockwise, it's going to be negative. So it's all relative from 0 degrees. So alpha in parentheses is the specific rotation in units of degrees. The formal unit for specific rotation is degrees decimeter. So remember also this is important. You'll want to make sure to take note. Big point here, decimeter. So usually we use centimeter in lab, but in this case we do decimeter. 10 centimeters is a decimeter. Make sure always, whenever you perform your calculations, to utilize decimeter within these calculations. And then going forward, milliliter, and then per gram. And as they say, that we just utilize degrees in this situation, so that way that you know how many degrees away from your standard that this specific compound is. L is the length of the cells in units of decimeters, and C is the sample concentration in units of grams per milliliter. So this is the main meat of the subject. Make sure to reread this. Make sure to utilize as many materials online as you can to understand the concept at hand. So going forward, if we were performing the experiment, then we would be utilizing the polarimeter and calculating the specific rotation for a known sugar sample using Voigt's law. And so here, this is great. They give you everything here. Make sure that, again, that you understand the difference between the machine and the apparatuses utilized here. And so go here, make sure to go ahead and write up everything here within your procedure and to utilize everything here, like we've looked at the video where we connect the vernier polarimeter cables into the machine. And so going forward, this is everything that is normal here. Going down, this is, if you just go through here, it'd be everything that we've reviewed in the video at hand. And then here are the data tables. So you'll insert the data like we do every week, and you can either utilize this within your lab report, or you can make your own worksheet within Word. Everything's fine. Just make sure that you're using tables. Good organization practice. Clean organization is the most important part of a notebook, such that you can go in and perform it as if you were walking into a lab setting. Then data analysis. This is everything that we'd be utilizing in order to analyze the data within this software. Going down further, and again, this is a super short. Everything here is the meat of what would be going on within this experiment. Now, don't forget. Now, this is important. Like, take note here. This is the second portion here. This is the polarimetry to identify the unknown. Up here, all that we're doing is preparing everything and performing a very, very small portion of this. However, once you utilize this data here, make sure you don't skip the other part of it. So, there's 2 parts to go through the full lab manual when you're performing this whole thing. I would say go ahead and you can combine all the materials into one part. You can, do all the machine, all of the apparatuses all in one part. And then if you want to just write procedure, you can maybe say procedure 1 and then procedure 2, and then you can do the data analysis. And then go forward, same thing here, utilizing the data tables like usual. You can either format it whichever way that you want, that you do maybe, the first section, your data analysis, and then second section, data analysis. I don't mind whichever one, as long as that you make sure that you have both. So once again, I'll just repeat myself for clarity, making sure that everyone here understands, make sure to do both parts. If you email me and you say, hey, what do we do? I'm just going to say it again, like straight out. I'm just going to say, do both parts. So data tables once again, and let's see. I want to make sure here just before, in case anyone emails me, data analysis. So yeah, this would be the performing the data analysis such that you were performing the experiment at hand. So I'm not really seeing any post-lab calculations. So I'm going to go ahead and ask Dr. Rastogi about post-lab calculations here, because I'm actually not seeing any for this week, which is unusual. So I'll get back to everybody on that after this class. I'm going to go ahead and email him and clarify, hey, what about data analysis? So going forward with the data tables, we can see if your first name starts with A through I, utilize these. and then utilize Voigt's law in order to calculate your angle of rotation. Super simple. Just review that one. Let me again change this a little bit. Okay. J through R, same situation here. Super simple. Most of your time spent this week will probably be just typing out and setting out your data tables and then performing your calculations. So yeah, super small lab today. I'll make sure, I'm gonna go ahead and write a note right here so that way that I can email him to make sure that if there is a post-lab section, that we do have that for everyone. Okay, wrote it down. So I'm going to email him right after this, and then that way that we can make sure that we get our lab notebooks completed correctly. And yeah, so, pretty simple lab this week, only polarimetry. Make sure to review the lab manual. And honestly, it's really short sections. So I would say utilize, the modules to watch some videos, review them, and go forward. YouTube, Google, all your best friends. Super short lab relative to the other ones. So yeah, looks like that we have come to the end of our lesson. So I'm gonna go ahead and stop recording, and then we can get into any questions that people may have.